Okay, you are not going to believe this. I have recorded 3 videos and I've had trouble with the graph, so I stopped it, fixed my problem, came back, recorded another video. I was going to just give you 2 videos. And then I realized that I had the stupid microphone muted again. See, my microphone is not muted. I've tested it. For the love of math. All right, here we go. So this is a list of your problems. We're going to pick a few. I'm going to work on a secant or a cosecant one. I'm going to work on a cotangent one. And then I'm going to work on this one. So I want to work on the cotangent one because that one gave me the most fits, and I want to get that one out of the way first, and it'll make everything else seem easier. All right, so I'm going to go click on here and hope that this works. Okay, so here's your problem. And what I'm going to do is I'm going to hit practice this problem again, and it should let me start over. However, I did figure out a glitch, and this is a problem. So I'm not going to do this problem because what happens is that we run out of graph, and there's no way I cannot figure out a way to make the graph bigger. And I have fiddled with it and fiddled with it, and that was one of my mute videos. So I'm going to cancel that one. I'm going to try it again. Which one was it? This one? Cross your fingers. Okay. Okay, wait. Practice. Practice problem again. Hopefully it gives me a 2. Yes. Okay. All right. I'm not going to spend time telling you what happens with the 4. I'm actually going to submit that to tech support because I don't know, and maybe it's not clear. Maybe you know how to make my graph bigger. But nonetheless, this will work. Okay. So since I'm starting with cotangent, I'm starting over again, I need to go over here. What I wanted you to do was go to the lesson and look at this summary. This summary has a table. This is your standard form of a function. Okay, the letters A, B, C, and D are all these different numbers. The funky looking, cursive looking F represents any function. Okay, and it tells you that down here. So it's going to be a secant, a cosecant, or a cotangent in this lesson. Okay, so where'd I go? Right. A, the number out front, vertically dilates it. So you take the y values of all your points and you multiply it by A. Okay, if A is negative, it reflects it across the x-axis. But again, if you multiply all the y values by a negative number, it'll help you do that. Okay. The B is the hardest one. It dilates the graph horizontally, so it either makes it fatter or skinnier. And so the whole point of this problem is to find out what B is, and then once you get the B outside of it, then to figure out whether it stretches it or scrunches it, you do the reciprocal of B. So if the reciprocal of B is a fraction, it scrunches it. If the reciprocal of B is a whole number, it stretches it. I'll show you that. So this is where we start the graph. So the best way I figured out to do the graph is once we know B, we do B, then A, then C, and then finally D. It's kind of like the order of complexity. B's hard, A's kind of hard, C is a little bit better, D's a little better. C and D, we shift all the points, every single point, the same amount, one way or the other. C is horizontally. If there's a minus sign in the parentheses, we go right. If there's a plus sign in the parentheses, we go left. D is the thing tacked on at the end. Plus means up and minus means down. And every point goes up or down, same number of places. Okay, there's some more, basically what I said talks about this right here. All right, so with that being said, we want to get B. B's been multiplied through in here. So we want to factor it back out so it looks like this. So we're just going to do a little bit of algebra. This is the same on whether it's cotangent, cosecant, or secant. Okay, so we're just going to look at the x over 2. Remember that it's really 1x over 2. That's a 2 minus 1 pi over 2. So to factor out the b, you're always just going to divide everything by the number that's next to the x. So when half is next to the x, we're going to divide. Change colors. Why won't you change colors? We're going to divide everything by 1/2. Okay, 1/2 divided by 1/2 is 1. The 1/2 doesn't go away, it just goes on the outside of the parentheses. So x is left. In this particular case, we got lucky, and this fraction cancels out, and we're just left with minus pi. Okay, sometimes you get a fraction in here, so do fraction math. Sometimes you get a whole number in here, so do the math. Okay, and probably the other problems will show that math a little bit better. So there we go. That's the part of the equation that changes. Everything else stays the same. So 2 cotangent parenthesis 1/2. Then we do another parenthesis and then x, and it's minus pi, close the parenthesis, then plus 1. Okay, so see how it's the same except for I factored out the half. Step. Okay, now then, like I said, we want to start with the b. The b is the 1/2. So based on the lesson, we take the b and we do the reciprocal of it. Define the scrunch. Well, the s, I'm going to call it the s factor. The s can stand for scrunch or stretch. Okay, the dilation factor, we probably should do a d, dilation factor, is 1 over b. 1 over b. b is 1/2. This is b. So 1 over 1/2 is the reciprocal of 1/2, which is 2. This is a 2. Oh my goodness, that's a horrible 2. I think I can use my finger. I'm so old that I forget that. Oh my gosh. Use the finger. Okay. All right. So what that means is that we're stretching it. Okay. So I want to show you what that looks like. I use mathway.com/graph. It's free. You can just do graphs in here. Unfortunately, you can't like pick a point, which makes things. Anyway, so here I already have cotangent, a regular old cotangent. Okay, so this looks like our graph currently. Okay, if we just throw in the scale factor, so remember it's 1/2 x, it knows what that means, stretch it out. Okay, so you can see the space between the two places of the original graph, and now look how much farther apart they are. They're stretched out. Okay, so that's the first step, is to stretch them out. Okay, so the scale factor is 2. So notice the distance between these 2 points is 2 tick marks. So 2 tick marks times 2 means 4 tick marks. So we're going to move this over here, and now there is 4 tick marks. 1, 2, 3, 4. Now then, there's 3 points here, so we have to move this one too. Notice the distance between this point and the original point that was here, it was 1 tick mark. So 1 tick mark times 2 is 2 tick marks. So this moves here. Okay? The scale factor was 2. We took the number of tick marks and we multiplied by 2 and moved everything away from each other. We moved this stuff away from each other so that we had that space. Okay. So that took care of the half. Now we're going to go to the A, which means you take every point y value and multiply by a. So in this case, multiply by 2. This y value is 0. So 0 times 2 is 0. This y value is 0. 0 times 2 is 0. This y value is 1. 1 times 2 is 2. Boom. Okay. So we took care of the 2. Took care of the half. Now we're going to shift to the right. The minus sign inside here means go right. We're going to shift it high. Right? High spaces. Okay. This point is at pi. So to move it to the right, we go another pi. So this point will move to here. This point moves pi over here. This point is half pi, so it moves to the other half pi, which is here. Okay? So we're moving at pi. Moving this one from half pi to the other half pi right here. Okay, it's the same number of tick marks too. 1, 2, 3, 4, right? Okay, and then we move this guy over here. So we shifted everything by pi units to the right. All right, that takes care of everything. Now we shift everything up 1. Shift everything up 1. So this goes up 1, stays there. This goes up 1, this goes up 1. Okay? Submit the answer. Yay. So that's cotangent. And I still see that my mute is off. Keep your fingers crossed. Okay. All right. So I'm going to go back over here. So that was the cotangent. So let's just, this one's right here. Let's just look at this one. Because the secant and cosecant only have 2 points, but the idea is still the same. Okay? So here's your problem. And that's what, anyway, practice problem will be slightly different. Okay. First step is to get the b by itself. So we divide everything in this parenthesis by that 3. So let me get this little thingy over here, and let me use my finger. So 3x, what if I have a stylus? Will an eraser work? No. Okay. Next time I do this, find a stylus. Okay, so we're going to take that, then we're going to divide everything by the number that's multiplied by the x. Okay? So what that does is it moves the 3 to the outside. Okay? Leaving the x. This, we just leave it alone. We don't have to do math here. We just leave it as the fraction as you see it. Voila. So there's your b. So let's go ahead and take care of that. So if b equals 3, our scrunch, scale factor, dilation factor, horizontal, weird factor is 1 over 3. Okay? Okay, so first of all, let's write this equation. 3 secant parenthesis 3 parenthesis x plus pi over 3 pi over 3 close minus 1. Okay, now we sketch the graph. So again, we always start with this 3. Okay, so that means b is 3. The scale factor is 1/3. So this one's going to get squeezed. So let me show you over here on Mathway. Close this. Cancel this. So this is secant x not sec, sorry. Secant x, good grief, this is not health class. Okay, there's our regular graph. Secant of, shoot, I forgot the number. Where are we? What happened to it? What happened to it? Ah, this stupid recording thing is in the way. All right. 3. 3, 3, 3. Okay. 3x. So this is the lavender. Notice, see how it gets skinny? Skinny winny? So we want our graph to look skinny. Is that here? I hope you can't hear my dog barking, but it's driving me crazy. Okay. So let's count tick marks again. Right? So from here to here. 1, 2, 3, 4, 5, 6. Okay? So we are doing a third of 6. What is a third of 6? Is 2. Okay? Are you following me? If it was half a 6, then it would be halfway, right? 1, 2, 3. We would do 3. But it's not half, it's a third. I have to go get my dog to shut up. Okay, so there's six tick marks. T for tick marks. Right? Times a third, that's the scale factor. So it's really, use my finger, 6 divided by 3, which is 2. So we want it to be 2 tick marks apart. Okay. So I'm going to move this guy closer by 2 tick marks. 2 tick marks? No. No, it has to be 2 tick marks from this one. So I'm going to move this guy over here. 1, 2. So that's skinny, like this one. Yes. Ugh, wrong one. Okay. Okay. So that's this 3. Now we're doing this 3. Multiply every y value by 3. Every y value. 0 times 3 times 0. 1 times 3 times 3. And it is positive, yes. Okay. Now we shift everything over pi 3. Pi over 3. We shift everything to the left because of the plus sign. Everything to the left, pi over 3. Okay? Pi over 3. Pi over 3. Okay, so pi over 3 is a third is greater than a fourth. So I'm just going to move this over here. Pi over 3 is pi over 12. So each one of these tick marks is a 12, right? So each tick mark is a 12. So how many 12s is a 3? Okay, I just confused myself with that. Okay, hang on. What are we doing? Okay. 2. Oh, no. Tick marks. 6. No, that. What am I doing? Right here. We're moving it over pi over 3. So we're at this point is at pi over 6. So let's think about that. I'm gonna get rid of this. Think about pi over 6. How many? What do I have to do to get to pi over 3? Is it, so 1/6 plus 1/6. So every 2 tick marks is a sixth, right? So a sixth and a sixth is 2/6, right? Which is 1/3. Okay? Does that make sense? 2 tick marks is a sixth, and I want to get to a third. So if I go, this is 2 tick marks, this is 2 tick marks, that's a third. I hope that's right. I'm like starting to second guess myself now. So we're moving it over to another sixth, like a third. Okay, another way to look at it, a third is 2/6. 1 pi over 3 is the same thing as 2 pi over 6. This is pi over 6 and it's 2 tick marks. So we're going to move everything 2 tick marks to the left. So this one goes 2 tick marks. See, it's on the third. This one goes 2 tick marks. Okay? All right, and finally everything goes down 1. Everything goes down 1. 1, 1. And hoping for the best. And I did it. Oh, dang it! Did I move one? Okay. Let's see if I can quickly get back to where we were. Where were we? Let's go to each other. Where is the second one? Let's look at the graph really quick. Look at the original points. I apologize. Dang it, we were almost clear. We were almost. All right, does it tell you that? No. I wish you could undo. I just. Where the heck am I? There we are. The original one is at 0 and pi over 2. Okay. I don't need this one anymore. Let me close this one. It keeps confusing me. Okay. Okay, this is the original graph. Taking it to the scale factor. The scale factor was 3. I'm thinking it was just a small error. I'm hoping it's just a small error. Okay, so B is 3. So the scale factor is 1/3. 1/3. Okay, 1/3. 1, 2, 3, 4, 5, 6 tick marks in between them. So a third of that would be 6 divided by 3. 6 divided by 3 is 2. So that means that there needs to be 2 tick marks. 1, 2. Check math way. It's 3. Right, zoom in. Right. Originally it was 1, 2, 3, 4, 5, 6. And now it's 1, 2. Wait, we can look up here. It's hard. We have to go by these dumb points. Okay, I think that's right. Then we move everything up by 3. Not everything, no. Close. Multiply the y values by 3. So, oh, this guy needs to go back to 0. Sorry. My original is at 1, and I didn't get it quite back to the original. Okay, the 2 tick marks is fine. So this needs to be times 3. 1 times 3 is 3. 0 times 3. Okay, now then, I bet it's this. Moving it over pi over 3. Pi over 3. So if I was moving this over to pi over 3, I probably didn't go far enough. This guy is got to go, it's at 0, it's got to go left to pi over 3, which is here. And they're 2 tick marks apart. Okay, so this guy is going to go 2 tick marks on the other side of pi over 3. This is pi over 3, 1, 2. This goes to pi over 3. Okay, so this, it shifts pi over 3. So this was at 0. It's got to go a distance of pi over 3. That's where it is. They were 2 tick marks apart. So wherever this is, it's got to be 2 tick marks over. And everything moved left because of the plus mark. Okay, and then the minus 1. The minus 1, I hope you're a praying student. So minus 1 means everything comes down 1. Down 1, are we leaving at pi over 3? Down 1. Okay, here we go. Here goes nothing. Okay, so I didn't move it enough with my shift. So I'm hoping that pi over 3, the way I did that, I'm hoping that helped with you. Okay. All right, this video is getting long. So I did, I don't know, I'm tempted to do another one, but I'm worried that I'm worried that I'll mess up and have to go back and correct myself. Where are you? Okay, I wanted to look at this one. Okay. So this is leading into the identities, which is the next chapter, which I noticed that I think you've already started. And identities can be kind of confusing too, but at least you don't have to deal with their dumb graphing program. All right, let's practice this problem. Okay, so I had trouble with these because of the wording. Consider the function cosecant x, which is defined as the reciprocal of sine x. So cosecant is the reciprocal of sine. So cosecant is the same thing as 1 over sine. In fact, when you do this on old school calculators that only have sine, you do your sine function and then you take the reciprocal of it to get the cosecant, which works great except for when you have the undefined, which is what they're trying to tell you here. They're trying to get you to figure out the undefined. What's undefined? So part A, which of the following describes the value of x where sine of x equals 0? So right now, all we care about is sine. Okay? And I'm just going to use my, I mean, you can use your calculator, but just use math away. All right? Go over here. We're just going to do sine of x, closure. Sine of x. So where is sine 0? Sine is 0 at 0 and at negative pi and at pi. So notice it's period, I think is what this is called, is pi long. Okay? So is that over here, over here, over here? There we go. Okay. So what we're looking for is we're looking for just pi. Here we go. So what this means is that pi times any number. That's not right. That's not right. Where n is, it's 0 at every pi, where n is an integer. So look at this. Okay, so look, it's 0 at pi, it's 0 at 2 pi, it's 0 at 3 pi, it's 0. 4 pi. So n represents the numbers in front of pi. So it's 0 at some uh, factor, multiple, whatever you want to call it, of pi. Okay, I keep clicking on the wrong one. I apologize. So we're looking for pi. So it's 0 at pi, every pi. It's not pi plus half a pi. It's not 2 pi. It's at every pi. So that's what we're looking for here. Submit this step. Okay, so now it's saying, okay, based on your answer here, what about cosecant? What can we say about it? What does that imply about it? Well, if sine is 0 at every pi, the inverse of 0 is an undefined. If you do 1 divided by 0, it's bad juju, right? Your calculator blows up. Okay? So that means that wherever it's 0, it's going to be undefined. All right? F of x is undefined when x equals. Right? So this part, this x equals pi over n, is x equals pi over n, that's going to be the same. What we're looking for is this. Okay? It's undefined. Okay? Which is this one? This one. Okay. So let me look here. Let me try to find another one. I'm not finding tons of the graphing ones. I wanted to do another one like that, but with a different function. Let's consider, what did it look like? Which one did I do? If you're here, you can tell me. Oh, here we go. Okay, that's the one we did. I only see one of that. Okay, so just on those ones, well, I'm already at 33 minutes. The key to those is look at the graph of them and find the period. And then a lot of times they're going to tell you, like with cosecant and secant, it's probably going to be 0 and undefined. And then with cotangent, the same thing. Um, I'm tempted to do another graph just to I can't actually even remember which one we did. Oh, divided by 2, divided by 2. Let's 3. Let's look at this one because it's going to be another weird fraction here. Of course, I know you have the ability to pause the video and say, like, I already got it after the first time. Okay. I've struggled with this myself. I just want to make sure that I'm doing a good job of teaching it to you. Okay. So, first step is to get the b by itself. So, we're going to do 3x plus pi. And we're going to divide everything by 3. Oh, this didn't help you with the fractions, but so 3 is going to be on the outside, and it's going to be x plus pi over 3. That's just like the one we did. with the pi over 3. Okay. I don't want to repeat that one. This is the one I thought we had. Oh, it didn't give me, oh. It did, because it depends. It's going to change the numbers on me. Well, I feel like I need to leave you. I want to do one more for you. Let's just see what the practice problem pops up with. Come on. Rolling the dice. It's going to be by half. Okay, well, let's just get her done, because I want one more example. Okay, so 2x plus pi. So I'm going to divide everything by 2. So I get the 2 on the outside. Okay, so b equals 2, so our scale factor is 1 over 2. Okay. Write the equation. 3 secant parenthesis 2 parenthesis x plus pi over 2 close parentheses minus 2. Okay. Okay. So first part is the scale factor of a half. So let's look at this. So 1, 2, 3, 4, 5, 6. So half of 6 is 3. 1, 2, 3. So we're going to move this guy over to half. Okay. Then multiply the y values by 3. Okay. Then we're shifting. We're going left pi over 2. Left pi over 2. Okay, so this guy goes to pi over 2, left. And then since this guy is moving all the way over here, this guy is 4, 1, 2, 3 tick marks. So it's got to be 1, 2, 3 tick marks. Okay? So this guy is going to go here. This guy goes to pi over 2. Right? Pi over 2. And then we go down 2. Everybody goes down 2. Everybody goes down 2. 1, 2. 1, 2. Voila. Okay? Sorry that the video is so long. I'm sorry I struggled in that one, but maybe it helped. Maybe it helped you seeing me work it out and realizing where I made my mistake. All right, my favorite phrase is endeavor to persevere, and that's what we did. All right, I hope this helped you. Talk to you later.